Hello, today we're going to talk about a half lesson that falls between lesson 5 and 6 in our unit 7 here. We're talking about sides and angles of triangles, and this is something we've already touched on in a couple of previous lessons, the fact that the three angles of a triangle always add up to 180 degrees. We will do some more with that, but first we're going to talk about the sides of a triangle. So at the top of your handout, you should hopefully see this paragraph of information. We're going to fill in some blanks together. We're also going to adjust what it says just a little bit because I think it makes it easier to work with. So this says the sum of the lengths of any, and this is where we're going to do a little adjusting. We're going to cross out the word any and put two shortest. All right, so the sum of the lengths of the two shortest sides of a triangle is greater than the length of the third side. That is basically what you need to get from this. That's the important part here. So when we add up, that's what sum is. When we add up the lengths of the two shortest sides of a triangle, it's got to be greater than the length of the third side. Now, if you take the three sides of a triangle and add them in pairs, the sum is greater than, but not equal to the third side. If that's not true, then it is impossible to construct a triangle with the given sides. And let's take a look at this example before we try to explain it any further. I think the example will really help kind of clear up what we're talking about. So determine if sides of length 5, 8, and 12 centimeters can form a triangle. Going back to our rule, we're going to add the lengths of the two shortest sides, and those two shortest sides would be 5 and 8. So we're going to add those up, and that will give us 13 as a sum here. And remember, as long as the two shortest sides are greater than the length of the third side, if the sum of 13 is greater than 12, then we have a triangle. So yes, this will create a triangle. For the next one, we'll take the two shortest sides, which is 3 and 4, add them together to get 7. And 7 is not greater than 9, so this would not create a triangle. All right, just a couple of days ago, we did an activity where we had a line and it had different points on it. And then we looked at some different expressions that represented different lengths on here. And it said if you have A, B minus part of it, then is it equal to the length of CD? That kind of an idea. So going off of that idea, if we were to look at this example here that didn't make a triangle, okay, so if we say the length from A to B is 9 feet, like the example here. If we have one side of our triangle that's 3 feet, that would go to about there, and the other side of the triangle is 4 feet, that would go to about there. Hopefully you can see that that would never make a triangle because we have to connect our points here. And what we're going to have is two sides that can't reach one another to make that third point. It has to be longer to get that lift in the triangle and get this third point up here that we need. So that's how this rule works. We're going to look at some examples here, and this certainly would be a quiz question you could come across, but it's asking, does a triangle with these three sides make a triangle? Can you have three sides of this length and get a triangle, yes or no? So again, we're going to find the sum of the two shortest sides. In this case, again, it's the first two sides, so we'll add those up. And if 7 is greater than our longest side, which is 5, then yes, 7 is greater than 5, so we do have a triangle here. That's the idea for this. Pay attention to what your two shortest sides are. So like on B, our two shortest sides are not side by side this time, but they have a sum of 9. 9 is greater than 7. Yes, we have another triangle there. I want you to go through the rest of these and determine whether or not it would be a triangle. All right, let me fill that in real quick. So we have no for triangle C and triangle D. Triangle E is yes. No. Yes for G. No. Yes for I and J. The next three are no. And the last two are yes. Okay? All right, I hope you didn't find that too difficult. For the next part, this is something that takes this idea and takes it a little bit further. So pay close attention to these, please. So it wants us to predict the length of the third side of the triangle with sides of length 12 feet and 16 feet. Okay, we're missing a side here. We don't know if 16 is the longest side of the triangle or if there's a third side that's the longest side of the triangle. So to answer a question like this, we can't just give one answer. Now, we know that if 16 is the longest side of the triangle, then 12 and this other missing side, let's just put a blank here, 12 and this other missing side has to be greater than 16. Well, 12 plus 4 is 16. So if I were to have 4, now granted that would not make a triangle, so please bear with me for a second. If I add 12 and 4 and I get the same result as my longest side, it's not going to create a triangle. What it's going to do is it's going to make two lines that are the same length. There's still not that extra length that's going to lift and make that third point of the triangle. So 4 will not work as a triangle, but it's my starting point. Technically, anything greater than 4 would work. If it's 4.1 or 4.2 feet, that is going to create a tiny sliver of a triangle. So we're going to be writing our answer kind of like an inequality, I think would be the best way to show it. That we can't equal 4, but we can be greater than 4. That's going to be our side here. And we can get too big with this other side. So we have to be careful. If 16 is not my longest side, that would make 12 and 16 my two short sides. When I add those together, we get 28. And 28 is going to be the, what a side length of the triangle would be, that would be too big. So we need to stay under that. We need to write an inequality like this. We're basically saying that our side of our triangle must be greater than 4. Okay, that would make 16 the longest side. And it must remain less than 28, because if 28 was our longest side, I'm sorry, it couldn't be 28. It's got to be less than 28 to still create a triangle with these two side lengths. I hope I didn't lose you. I do have an easier way to explain this. I just want you to kind of understand the reasoning behind it, okay, of why we pick these two numbers. So the easiest way to do it is to just take the two sides that you're given, first subtract, then add. So if you look at our example here, 16 minus 12 was 4. 12 plus 16 was 28. That gives me my two parameters, my two outer numbers that I have to stay between. I can't equal either of those numbers. I have to be in between them. So looking at this next one, if we have a side of 13 and a side of 20, first thing I'm going to do is subtract them. So 20 minus 13 will give me 7. 20 plus 13 will be 33. And as long as my value is greater than 7, but less than 33, we will have a triangle. Go ahead and try that for our last example, please. And hopefully what you came up with was a value but greater than 12, but less than 26. All right, that's the idea for today's short lesson. Jump to the back. I just want to show you a couple examples where we are working with the angles of these triangles. And please, right at the top of your paper, write this quick reminder: all angles of a triangle have a sum of 180 degrees. All angles of a triangle have a sum of 180 degrees. So, looking at this first one here, I can be assured that these three angles, when added together, will equal 180 degrees. Now, I could write an equation to show that I'm adding these three up and then solve for x, my missing value. But that equation is going to equal 180 every single time. The same thing is going to happen here. And notice for these first two and for several others, we're finding the value of x. Whatever we get as this missing angle is the value for x. But that's not the case for example 3, and let me show you what I mean. So we know it's a triangle. We know that all three angles are going to add up to 180 degrees. We have an angle that's 31, and we have a right angle here of 90. So I'm going to just start by combining those. I'm going to add them together. 90, excuse me, 90 plus 31 would give me 121 plus, and now in parentheses here we have our third angle, 3x minus 1. All right? I need to solve this equation for x, and this is where writing an equation is going to be really important. So the first thing I would do is get rid of this 121. I'd subtract it, and that would leave me with 59 degrees. And I would rewrite this as 3x minus 1 equals 59 degrees. Now I need to continue solving for x, because what this tells me right now, when I'm saying that 3x minus 1, which is what this angle is called, is equal to 59 degrees, this right here is a 59 degree angle right here in the corner. And if I checked, if I added up 90, 31, and 59, I would get my total sum of 180 degrees. But the question wants us to find the value of x. So I have to keep solving. I have to cancel this minus 1. I have to add 1. Okay, if I add 1 to both sides here, now I've got 60. 3x equals 60. And then I'm going to divide it by 3. So once I do that, 60 divided by 3, I get my value for x, which is 20. That would be your answer. 59 is not the answer to this question because it's asking for the value of x. Please be really careful when you're doing this, because some of these are still going to just ask for this angle x, while others are going to ask for you to continue solving this. Once you get the total of the angle, continue solving it so that you know the value of x here. All right, go ahead and check the answer key at the end of the video. I will happily answer any questions you have on Zoom, and then we'll continue on to lesson 6 tomorrow. Everybody have a great day.